All right, welcome to The Explainer. Today, we're tackling something that sounds like it's straight out of science fiction, but it's rapidly becoming science fact. I'm talking about quantum computing. We're going to get into what it is, why it's such a massive game changer, and how it's being built to crack problems we used to think were, well, literally impossible.
So you gotta ask, right? Why are we even bothering to build computers that completely break the old rules? Well, it's because for all their incredible power, the computers we use every single day, they've kind of hit a wall. They're amazing at logic, at order, but they choke when they come up against the messiness and complexity of the real universe.
And when I say they choke, I'm not exaggerating. We're talking about problems that would take the computers we have now thousands, maybe even millions of years to solve. Yeah, you heard that right. These aren't just tough math problems. It's a whole different level of complexity. Think about trying to design a new life-saving drug by simulating every single atom's interaction. That's a puzzle it's completely out of reach for the machines we have today. So, to tackle these massive challenges, we can't just build a faster computer. That's not going to cut it. We need a totally different kind of computer, a whole new way of thinking that plays by the weird, powerful rules of the subatomic world. We need, well, a quantum leap. Okay, so let's break this down. Our whole digital world, from your phone to the most powerful supercomputers, is built on one simple idea, the bit. And you can just think of a bit like a light switch. It's either on, which is a 1, or it's off, a 0. That's it. Simple. Billions and billions of these tiny switches, all flipping on and off, give us literally everything we do digitally. Quantum computers, though, they just take that rule book and toss it right out the window. They play a completely different game, using the seriously weird and counterintuitive laws of quantum mechanics. And they do it all with this revolutionary new building block, called the qubit. Okay, so this is the absolute key difference, right? A regular bit is that light switch, on or off, one or the other. A qubit, well, you could say it's like a dimmer switch, but honestly, even that doesn't really do it justice. Because of this amazing quantum property called superposition, a qubit can be a 0, it can be a 1, or, and get this, it can be both at the very same time. That one little trick is why their power doesn't just add up, it explodes exponentially. So how in the world does a qubit pull this off? Well, it's not magic, even though it kind of sounds like it. It's pure quantum mechanics. And this incredible power comes from tapping into two bizarre but totally fundamental principles of how the universe works. Okay, superpower number 1 is called superposition. This is the big one we just mentioned. It's what lets a qubit hold both a 0 and a 1 at the same time, basically letting it explore a huge range of possibilities all at once. It's like it exists in this haze of pure potential, right up until the moment you actually measure it. Here's a great way to think about it. Imagine flipping a coin. While it's spinning in the air, is it heads or tails? Well, in a quantum sense, it's kind of both. That spinning coin is like a qubit in superposition. Now, a regular computer would have to wait for it to land, check if it's heads, then flip it again and check if it's tails. A quantum computer gets to look at all the possibilities while the coin is still spinning. It's a massive shortcut. All right, on to the second superpower. And this one is even weirder. It's called entanglement. Albert Einstein famously called it spooky action at a distance, and for good reason. This is where you can link 2 or more qubits together so their fates are intertwined. They basically act like a single entity, no matter how far apart you pull them. And this connection is the real secret sauce. If you measure one of these entangled qubits, you instantly, and I mean instantly, know the state of the other one, even if it's on the other side of the galaxy. It's this link, which seems impossible in our everyday world, that lets a quantum computer process a ton of information in parallel. And that's what really fuels that insane exponential growth in power. Okay, so you've got superposition and entanglement. These are our quantum superpowers. But what can we actually do with all this? Let's talk about how this moves from mind-bending theory to actually solving some of the world's biggest problems. And look, this isn't just some far-off dream. This is happening now. Back in 2019, Google's quantum machine, Sycamore, solved a problem in just 200 seconds. So what, right? Well, the crazy part is that they calculated it would have taken the world's fastest supercomputer about 10,000 years to do the same thing. That was a huge moment. It was basically the quantum era's version of Hello World. Now, the tech is still super young, but researchers are already zeroing in on a few key areas where this could be absolutely revolutionary.
The biggest one by far is chemical simulation. And that makes perfect sense, right? The universe is built on quantum mechanics, so it figures you need a quantum computer to simulate it perfectly. After that, you've got things like optimization, finding the best solution out of a bazillion possibilities, and even supercharging machine learning.
So what does this mean for you and me? Well, it translates to massive real-world breakthroughs. We're talking about designing new medicines, literally molecule by molecule, instead of just guessing. Or in logistics, like Volkswagen showed, it's about finding the absolute best shipping route from millions of options, instantly. And cybersecurity? Whoa, that's a real double-edged sword. These machines could potentially break all our current encryption, but they could also help us create new, truly unhackable codes.
Okay, with all this mind-blowing potential, it begs the question, right? Why don't I have a quantum laptop sitting on my desk? If this stuff is so powerful, what's the holdup? Well, here's the reality check. We are still in the very early days. You see, the same quantum weirdness that makes qubits so powerful also makes them incredibly fragile. Their greatest strength is also their biggest weakness. The tiniest vibration, the slightest change in heat, any little bit of noise from the outside world can knock them out of their quantum state. That's called decoherence, and it just wrecks the calculations. Honestly, just building and shielding these things from the world is one of the biggest engineering challenges of our time. And the experts in the field, people like the famous physicist John Preskill, they tell us to keep a level head. He reminds us that quantum computers aren't going to replace your laptop for checking email. Think of them more like a specialized surgical tool, not a Swiss Army knife. They're being built to solve a very specific set of ultra-hard problems that our current computers just can't even begin to tackle. But on the other hand, you have industry pioneers like Ilana Wisby, who see a future that is going to be completely transformed by this. They really believe quantum computers are the key that will unlock the next great wave of human innovation, totally reshaping science, business, you name it. And then you've got people like Christopher Savoy who point to these incredible, tangible things we could do. Imagine being able to perfectly simulate molecules to design a material that literally pulls pollution out of the air, or creating a fuel cell that's 100% efficient. I mean, these are the massive, world-changing goals that suddenly seem possible with this technology. So when you boil it all down, the takeaway is pretty clear. This isn't about getting a faster way to binge watch shows. This is about building a completely new kind of tool, one that lets us understand the universe in its own native language. We're really just at the end of the beginning here, but that next leap forward could completely redefine what we think of as possible. So the real question to leave you with is not if quantum computers will change our world, but which part of it they're going to revolutionize first.